Hello everyone, now we are going to solve the questions based on the energy method. A rolling disk of R radius and M mass is connected to one end of a linear spring of a stiffness K as shown in figure. The natural frequency of oscillation is given by which of the following? See, this question can be solved either by torque method or by energy method. But we have solved the questions based on the torque method. You can see now these questions will be solved by the energy method. Okay, I will let you know about torque method also. So basically we are going to start this question with the energy method. Okay, so if I apply the energy method, you know very well what is the energy method we have studied in the topic. So when there is a system, you have to consider all the energy of the system. So here you can see if this is going to be rotated with an angular velocity omega. Okay, so what would be the energy? E would be equal to half I omega square, that is the rotational kinetic energy of the disk, half mv square, that is the linear kinetic energy of the disk, plus half kx square, that is the potential energy of the spring, half kx square. Now see here, what is the energy method? Energy method means in general in the natural vibration, because natural frequency are going to find out in the natural vibration, and there is damper is not given in the question. So basically it is the question of the natural vibrations. In the natural vibration, we generally don't consider kinetic friction. Are you getting my point? In natural vibrations, we don't consider kinetic friction, because if there is a kinetic friction, there will be a loss of energy. Okay, and since we are not considering kinetic friction, so that means energy will not be lost. Okay, if the energy is not going to be lost, that means energy remain constant. If the energy remain constant, that means differentiation of energy with respect to time is equal to 0. So that means I can write here, I'm going to revise the concept again. Okay, that is dE upon dt is equal to 0. Okay, so we have to differentiate this whole equations with respect to t and put it equal to 0. So that would be 2 multiply half. See here, can I write this omega as v by r? Because omega is not given in the question. Okay, so that's why I can write it as v is equal to r omega, and so we can replace omega is equal to v by r. Okay, v by r. So now just rearranging these equations again. So half I omega is v by r whole square. And can I replace this I? I is the moment of inertia, and for the disk it is half mr square. For the disk it is mr square by 2, because the radius of gyration for the disk is r upon the root 2. So that's why it would be I is equal to mk square. So that's why it would become mr square by 2. Okay, so I'm just replacing this value of I again. This is m r square mr square by 2 v upon r whole square, plus half mv square plus half kx square. Okay, so let us differentiate it. So you can see here that r square and r square will be cancel out. Okay, so it will becomes I e is equal to 1 by 4 mv square, isn't it? 1 by 4 mv square. Okay, plus 1 by 2 mv square plus half kx square. So you can see this is 1 by 2 and this is 1 by 4. So it would becomes 3 by 4. 3 by 4 mv square plus half kx square. Now we will differentiate this dE upon dt. is equal to 0. That means 3 by 4, m is constant, and v square will be 2v dv upon dt. That would become acceleration. Okay, plus half a 2x dx upon dt, because k is constant and m is constant, and remaining velocity and displacement is variable here. Now it is equal to 0. So you can see here that we can replace a is equal to, we know that a is equal to x double dot, okay, is equal to dv upon dt. Similarly, we know that v is equal to x dot, and it is equal to dx upon dt. So we will put this value in this equation above. You can see 3 by 4, and that would cancel out by 2. So 3 by 2 m v x double dot plus, and this to cancel out by this, and that would become kx x dot. Here you can see this would be x dot, and we know that x dot is equal to v, so that would be v is equal to 0. So you can see the equations become 3 by 2 m x double dot plus kx is equal to 0. So when you rearrange these equations, you will get x double dot plus 2k upon 3m x is equal to 0. So this is the equations of natural vibrations. When you compare these equations with the general equations, you will get here, this would be the term that is omega n square. This is omega n square, we all know that. So what is the natural frequency? Natural frequency omega n square is equal to 2k upon 3m. So it would becomes omega n is equal to under root of 2k upon 3m. So that is the final answer. Options is given, so options A would be the correct answer. So this was the energy method. Okay, if you want to apply the torque method, you can also apply. Torque method is easy to apply because this is less time consuming process. Torque method, I'm talking about torque method. Why torque method is less time consuming? Because in the torque method you just have to write down the equations by looking at the diagram. Okay, if the diagram is not given, you can draw. This is another thing, but the diagram generally is given. So you just have to write down the equations of natural vibrations by having a small angular displacement of the disk theta. Okay, so if you want to write the equations, so I'm just letting you torque method equations, and you can solve torque method. If you want to write the equations, you just have to assume that this disk is going to be rotated with some angular displacement theta in the directions. So you can see here about point contact point C, you have to consider. Okay, so there will be some angular displacement theta. Okay, so spring will be in the displacement in the horizontal directions, so it would be the displacement of spring. So this is nothing but r theta. Okay, this is the displacement r theta of the spring. Okay, so if you want to write down the equations, it would be I theta double dot plus k r theta, and the we are considering torque, so it would be multiply with r is equal to 0. So you can see here that I theta double dot plus k r square is equal to 0. Okay, and here you just have to put out the value of I. Since we are considering the rotation about point C, so that means we have to consider the moment of inertia about point C. So this is Ig plus m r square, that is r is distance between the center and the point of contact. This is equal to r, and Ig is nothing but 1 by 2 mr square plus mr square, so it would become 3 by 2 mr square. So when you put the value of I in these equations and just rearrange these equations, you will get 2k upon 3m theta. Here it will be theta is equal to 0, and so you can see here this is omega n square. So from here, if you get omega, that would be the same value. Okay. So I hope you will understand whether you apply the energy method or the torque method, the answer is same. But the thing is that the torque method required less time and less effort. You just have to write down the equations, but for the write down the equations, you need to practice a lot of questions. Remember that if you make any mistake to write down the equations, there will be wrong answer. Okay, so be careful about it. So thank you.